I'd like to sketch for you what I think is quite a challenging scenario which threatens real-world applications of causal inference. And it occurs when combining with the use of certain emergent artificial intelligence mechanisms. And my main message, I guess, is to be mindful. Be mindful of the system when worrying about the components. So speaking informally, I guess causal inference comprises two main problems to solve. The first is to construct a network from some data, a causal model, which can be represented as a directed graph. The next is to attempt to predict outcomes due to manipulations using that causal model. For example, as we've seen earlier today, a manipulation might be the administration of some change or treatment for an illness, say, or some other effect, and the prediction might be whether or not that is going to succeed or not. New slide, it says, so we will imagine the new slide. Let's look at some challenges, however, that arise when using agentic networks, that's an AI type, together with causal inference. So we're now building a big network of components that have interactions between them. So agentic AI agents, which are relatively new things, independently plan, execute, and manage multi-step workflows, usually across communicating networks of agents, and these agents maybe have no direct legal or other relationship with each other on the internet. And they may include agents as well as machines. And these systems can give rise to some interesting class of ethical challenge. And that's what I'd like to discuss today. I'd like to introduce the concepts of distributed moral actions and distributed moral responsibility. And these ideas are largely due to a philosopher called Floridi, who was publishing them about a decade ago. But I think they're becoming increasingly relevant now as we're seeing much more widespread applications of AIs over networks. And he wrote in one of his papers, I think 2016, in distributed environments, it is increasingly common that a network of agents may cause morally good or evil, henceforth loaded, actions through local interactions that are not in themselves morally loaded but neutral. So, for example, Alice and Bob may both cause effects that they believe are harmless, but these may conflate to cause harm and cause a consequential outcome, which might be a big bang. My background is in recent years is in information security, so there are lots of areas where big bangs occur because people behave in ways adversarially that we didn't expect. So that's a big area, but actually it's much more wider than that. So he describes two things. One of them is distributed moral actions which cause moral effects. I do something and there's a moral outcome, good or bad. But he also raised the question of distributed moral responsibility. Who is responsible for some given outcome? And DMR is a situation which ethics classically largely ignores, and the reason for that is it tends to concentrate on intentionality. So Alice and Bob had intentions which were perfectly good, but they were irrelevant to the Big Bang. Hence, he also observed that intentionality is not closed under causal implication. What that means is precisely because intentionality is not closed under direct or indirect causal implication. The assumption of intentionality of an action as a necessary condition for the ethical evaluation of it, is it good or bad, leads to an oversight, because ethics, generally speaking, cannot address DMAs, distributed moral actions and responsibilities. So in order to fill this gap, he proposed the idea of faultless responsibility. And this is the thing I think we must watch out for if we're supplying components into a bigger network, because we may find ourselves liable for things that are not directly the result of what we've done. So what you do essentially in this process is you identify the agents in a causal graph. You determine which of those are connected to a given moral outcome, the Big Bang, in one direction, and then in the backward direction, you ascribe responsibility for that outcome. Now, one of his proposals is that all agents that are linked in that backward propagation should be held faultlessly responsible for the Big Bang. Equally so, that was his proposal to address this thing. There are instances where this is done in real life in law at present, although many legal systems don't address this. And one of them is if I'm bicycling in Amsterdam. There is a rule apparently that 3 bikes may not bike alongside each other in Amsterdam. If 2 of you are moseying along quite nicely, that's fine, but if a third person joins, you're breaking the law. And that law is interpreted as a equal responsibility for all of the parties involved. So you could be happily biking along, somebody joins, make a 3, and you're all liable. That is the class of problem we are potentially facing, I believe, in systems that we're putting together now. So potentially then, this process may include all agents being responsible for some big bang, yet individually they are, in a sense, completely faultless. So my main message then is to beware when we think about applying our components in bigger systems. Why is this particularly relevant with AI, and agentic AI in particular? It's because the rising levels and the rising actual scale of deployment of automation in independent action of agents is growing at such a rate that this threat is rapidly increasing, non-linearly increasing. So my message broadly is, as we develop our approaches and deployments of causal inference agents, we should be very careful that, particularly in commercial applications, we are not opening ourselves up to liability for effects that we cause by defining those causal relationships in a wider network, that things like AI can rapidly increase in scale. I hope you found that of some interest. I apologize for not showing you the last slide, which was AI generated. So if there are any questions, happy to answer them. Thank you.
I do have one small question.
Small question.
Which is, we have heard a talk about kind of nudging people's behavior.
Yeah.
Another talk about how these AI could collapse.
Yeah.
And another talk about the moral responsibility of all the individuals. So how will, like, for example, would you be able to nudge people's behavior in some way to prevent this?
Yes, I agree, yes. But the thing that I am concerned about is the relative scales. So the rate at which humans increase on the face of the Earth is relatively slow compared with the rate at which AI agents are increasing on the Earth. And they will have biases of their own, as we know.
Exactly that. So we have a team who's focused on the intersection between AI and VI. And one of the things they're focused on particularly is how you build agentic models that are devoid of bias. In the trial, you get that, but of course, even though building the models have bias, and so it has the potential to suffer in a really damaging way.
Yeah. And the other thing I would add to that is that we often think, when designing a system, about the functionality we expect. We don't often think about adversarial influences that might seek to change that. So those two effects, the bias at scale and adversaries acting at scale through the same technologies, is an interesting situation. Yes.
Some way to.
Absolutely. Yeah. Okay, thank you, folks.